we're going to put the process in reverse in regards to the equations. What we have done up till now, and this is if you're still a little bit iffy in regards to your in regards to the graph, if you're a little iffy with regards to that and determining the values and all that, today hopefully will help you out a little bit because it's going to be the exact same thing. We're just putting the process into reverse. I'm going to give you the graph and you're going to come up with the equation. Okay? So the process will be that other direction now, but you're still going to be able to find and you're still going to have to determine the key elements to the equation. We have our base equation, y equals vertical phase shift, plus or minus the a sine, cosine, b theta minus horizontal phase shift. We still have that base general equation. And as I suggested to you yesterday, my suggestion to you is where we used to write SOHCAHTOA, your trigonometric guardian, on top of your paper here. My suggestion to you would be you write this base equation to your graphs of sines and cosines. Because you're going to be given an equation. You're going to be given an equation, and I'm going to ask you to come up with all these ideas, these four elements that we've been working with, amplitude, period, vertical, horizontal, phase shift. You're going to have to come up with these four elements and then develop an equation given this information. If I look at my values, I didn't label my y-axis. We have -1, 1, 2, 3, 4, 5, and 6. And once again, what you're going to have to do is determine these elements. You're going to have to determine the amplitude, the period, along with this, you're going to develop a B value, a vertical phase shift, and a horizontal phase shift. So you're going to have to develop these values here and then plug them into the equation and develop an equation. Well, when we were going forward with this, when I gave you the equation, I asked you to give me the graph. The first thing we always looked at was drawing in the prime axis, which was your vertical phase shift. That's going to be the first thing that you're going to look at also here. You're going to want to draw in your prime axis. Well, if I look at my graph, I have peaks at a value of 5. I have valleys at a value of -1. Where would we draw in our prime axis? Where could we draw in our prime axis? Where should we?
2.
Why do you say 2?
Because there'd be 3 above and 3 below.
That's exactly right. We want to divide this and split this in half. We want equal above and equal below. So I'm going to draw in my prime axis, which will give us our vertical phase shift at a value 2. What would be the next easiest thing to find once I draw in my prime axis? Amplitude. What's my distance to my peak? What's my distance to my valley? Well, if I'm at 2, I go up to 5, or I'm 2, I go down to -1. My amplitude would be what, Thad? 3. Well, amplitude would be a value of 3. Okay, so we have 2 of the 4 already. And those are the easiest of the 2. Now, the next thing that you want to find is the period. Well, the easiest way to find the period is to go from a peak to another peak or a valley to another valley. Peak to peak or valley to valley. If you try crossing the y-axis or the theta axis and neutral axis, then you might get boogered up a little bit in regards to if I'm going in the screen mode or in click, 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 click mode. Okay, which way am I going? Am I going down or going up the hill? So if I go from peak to peak or valley to valley, here's the valley, here's the valley. Here would be a peak, here would be a peak. Because if I go peak to peak, that is one complete cycle. If I go valley to valley, that is one complete cycle. The period is defined to us as the number of degrees from peak to peak or number of degrees from valley to valley. Will I go from negative 60 to 110, peak to, or valley to valley, or 30 to, let's see, 180 to 10, 210? Number of degrees that we have there, chi would be what? If I would go from negative 60 to 120, I'm sorry, what? 180 degrees. Or if I would go from 30 to 210, 180. I can't just add these two together because if I take 120 plus negative 60, that would give me 60, which is incorrect. You're looking at, you have to subtract these two values, 210 minus 30 or 120 minus negative 60. So minus the negative turns into a positive. In our equation, we need to calculate a b value. And how we calculated the b was taking 360 divided by our b. That's how we calculated the period. If we multiply both sides by b, and then divide by the period, b would equal 360 divided by the period. Period's 180 degrees. So I take 360 divided by 180, so we get a value of 2. Now, our last tidbit of information is the horizontal phase shift. This is where we have some gray area. Because every one of our, when we determine our equation, we have an infinite number of solutions. It depends on what we use as a horizontal phase shift. You can choose, and you have a lot of leeway in regards to choosing what you want to do with a horizontal phase shift. My suggestion, this is just only my suggestion, and I'm going to use it most of the time. Not all the time, there's going to be some that is going to fall out where I'm going to use something a little bit different. But this, most of the time, I'm going to say use a positive cosine curve. Because you're going to develop an equation and you can choose what you want. You can use a sine curve or you can use a cosine curve. My suggestion to you is use a positive cosine. If you use a positive cosine, where's your horizontal phase shift going to start you at? Positive. If you have a positive cosine equation, where's the graph of your equation? Where do you start your graph at? At a peak. Positive cosine, you start at a peak. So you pick a peak. And it does not matter which peak you pick. I'm going to pick 30 degrees. This gives me a peak. And when I'm at a peak, this gives me a positive cosine curve. So if I throw in all my information now, I have y equals my vertical phase shift, which we found is a 2. Since I'm using a peak, I have a positive cosine. I have my amplitude, which is 3. Cosine, my b value, which is 2. And theta minus our horizontal phase shift of 30 degrees. I also have a peak at 210. That is the correct solution. Theta minus 210. Suppose you wanted to say, I want to use this valley here, negative 60, and I want to use a horizontal phase shift of negative 60. Now I'm at a valley value. So now I don't have a positive cosine, I have a negative cosine. So we have y equals 2 plus minus 3 cosine 2 theta plus 60. Or if I want to use this valley, I can go minus 120. That would be fine. These are all correct. If I want to do some additional work here, I'd have to really play with this a little bit. But if I take a look, my gains of halves, I think I'm at a value of negative 15 degrees. Because I have 30 here, I have 30 here, so I would have negative 15. So I can write y equals 2 plus 3 sine 2 theta plus 15 degrees. That is correct. If I want to come over here and use this value, I'm going down, I would have minus 75. 2 minus 3 sine 2 theta minus 75. An equation, make sure you get y equals. All these are correct solutions. You have to see what works for you and what you see. It depends on what you see your horizontal phase shift to be. Let's see, we got 1, negative 2, and negative 3. Alright, draw in. Where would your neutral prime axis be? Where would be your prime axis? Okay, draw that in. Okay, you're trying to find the four elements, so you have to do very vertical horizontal phase shift. Draw in your prime axis. That will give you your vertical phase shift. Okay, then develop your amplitude. What's your amplitude have to be? Okay, then you can go from either peak to peak or valley to valley. Calculate the period, determine the period, and then calculate your B value. Check your answer with somebody around you as you go along. Then determine where do you want to start your graph at. You might have to do a little bit of math to find a peak. Just use your gains of has to find the peak. Okay, because I go from 0 to 90 degrees. I got a valley and a valley. My peak is halfway between the two valleys. Okay, so you can find your peak at that point and write your positive cosine curve one. Or, if you see something different that you want to use, go for it. You don't want to use a positive cosine curve. That's fine. Because something jumps out to me if you have a horizontal phase shift of 0, but that would start us at a valley value. You just have to make sure that you get a correct equation that corresponds to a valley start value for your theta start. Okay, write your equation down and check that with somebody around you. Compare it with somebody around you. Hannah, what do you get for an equation?
Y equals -1 plus 2 cosine 4 parentheses theta minus 45.
Okay. You could have a plus 45 there, depends on if you use that or that. Anybody use a negative cosine curve? What's your equation?
Y equals -1 minus 2 cosine 4 parentheses
Theta plus what? Theta plus 90. Alright. Or if we use this point right here, that would just simplify down to y equals -1 minus 2 cosine 4 theta, because you'd have a minus 0. You could also have a negative 90 here that takes us to, I'm sorry, this value, I guess, or this value here. There you go. So either one is correct there. All right, once again, infinite number of solutions here. If you want to go out and use 270, 180, that is fine. You can utilize them also. All right, go to the back side. Draw on your prime axis. Find the amplitude varied vertical horizontal phase shift. And develop an equation and check your answer with somebody around you. Once again, as I said before, you have an infinite number of solutions. So you may have a different equation than somebody is around you, and they both may be correct. Like I said, most of the time, I look at using a positive cosine curve. I go to a peak. But there's sometimes that may jump out at me that I can use a horizontal phase shift to 0, and I might have to do something a little bit different. And that's fine. Yep. Yep. Yeah, 0 plus, and you don't have to write 0 plus. Okay, cosine curve, start at what value? start looking at the graph, cosine starts at a certain point, sine starts at a certain point. When you have a positive cosine, or when you have a cosine, you start on the prime axis for peaks and valleys. Okay? When you have a sine curve, you start at prime axis for peaks and valleys, so you just look at that.
I'm pretty sure that's weird.
Because then she has two.
Did you do something with the what did you do? That's what I was gonna write. I was like, wait a minute, I can do sine. Why did I? Because I was like, okay. Yeah, that's what I was writing.
What do you have for the amplitude and the vertical phase shift? 0 for vertical phase shift, amplitude.
Oh, amplitude too.
Okay. Our prime axis would go right on the theta axis. So we are not shifting at all upwards or downwards. We're keeping theta axis and theta prime axis the same. So vertical phase shift is 0. Horizontal or amplitude 2 to my peaks and 2 to my valleys. Period. What do you get for the period here? What do you get for the period? What do you get for the period? 720 degrees. If I go from here to here, okay, or if I go from peak to peak, I have 720 degrees. What do you get for your B value? 0.5 or a half. Now the horizontal phase shift, okay, this one could be one that's subject to debate. You could utilize different values here. If you went to a nearest peak, you could go to 180 or 540. And that will tune you right into a cosine curve, positive cosine. So we have y equals our vertical phase shift, which is 0, so we don't have to write it, plus the amplitude 2 cosine 1/2 theta minus 540 plus 180. Both of those are correct. Anybody use a sine curve here? That is correct. If I use this point right here and add a horizontal phase shift of 0, I have a sine curve here, but we have to remember we're going down first. Okay? We're going down first, which throws a negative in with that. You just have to watch, if I use a sine curve, am I going downwards or am I going upwards? If you use a positive sine curve, you could use this 360, y equals 2 sine 1/2 theta minus 360. That is the correct value also. So once again, you have an infinite number of solutions. Depends on what you see. Questions? All right, we have about 15 minutes here. You have on page 54, 9 to 17. On page 54, 9 to 17, you are now developing equations. You're given graphs and you're developing equations. Tomorrow, for the people that are here, we'll just do 3 other problems here in class, and that will be all we are going to be doing tomorrow. We'll look at a worksheet and in-class assignment Thursday, Friday, and then we'll quiz this up next Tuesday. Review day on Monday, quiz on Tuesday next week. All right, questions? The rest of the time is yours.
I don't think there's
heading to?
I'm working at my parents' home.
Like they do every year.
So,
I can do both.
are you gonna be here tomorrow?
Yeah, I was just letting you.
I'll just print off. I'll just print off what I have.
Okay. Thank you.